In 2017, a train company in Japan issued a formal public apology. They sent it to every passenger. They posted it on their website. They expressed deep regret and acknowledged that a serious failure had occurred. The train had departed 20 seconds early. Not late, early, by 20 seconds. And they were sorry. To most people reading this from outside Japan, that sounds like a joke. A train that leaves slightly ahead of schedule and the company apologizes? In most countries, a train that arrives within 15 minutes of its scheduled time is considered on time. In some systems, 30 minutes is the standard. In others, the concept of a schedule is more of a suggestion than a promise. But in Japan, 20 seconds early is a failure. Because in Japan, the schedule is not approximate. The schedule is a contract. And a contract means exactly what it says. Not more, not less. Welcome to the world's most precise railway system. And today, we're going to find out exactly how they do it.
Let's start with the statistics, because they need to be stated plainly before anything else, because they are genuinely extraordinary. The Tokaido Shinkansen, the bullet train line connecting Tokyo and Osaka, one of the busiest high-speed rail corridors in the world, has an average delay rate of less than 1 minute per train. Not per route, per individual train, averaged across the entire year, including every weather event, every mechanical issue, every unexpected incident. The average delay of a Shinkansen train is under 60 seconds. The Tokyo Metro and JR commuter lines that crisscross the city operate on schedules down to the minute, sometimes the half minute, and hit those targets with a consistency that defies the scale and complexity of what they're managing. During peak morning rush hour, some lines run trains every 90 seconds, each one arriving, opening its doors, loading thousands of passengers, closing its doors, and departing, precisely on time, again and again all morning. When delays do occur on Japanese rail, and they do occasionally, anything over 5 minutes triggers a formal incident report. Over 15 minutes, and passengers receive a delay certificate, a printed slip they can present to employers as proof their lateness was not their fault. The fact that such certificates exist and that they're needed only rarely tells you everything about what the baseline expectation is. Compare this to the UK, where trains are officially considered on time if they arrive within 10 minutes of schedule. Or the United States, where Amtrak's long-distance trains average delays measured not in minutes, but in hours. Or most major metro systems globally, where a 5-minute delay barely registers as noteworthy. Japan isn't just better at running trains, they're operating in a fundamentally different category.
Part of what makes Japanese trains so punctual is simply extraordinary engineering and an obsessive, almost philosophical commitment to building systems that don't fail. The Shinkansen network is one of the most impressive feats of sustained engineering in human history. Since the first line opened in 1964, the year Tokyo hosted the Olympics, not coincidentally, the Shinkansen has carried over 10 billion passengers without a single passenger fatality due to a derailment or collision. 0 in over 60 years. This is not luck. It is the product of a design philosophy called poka-yoke, a Japanese term meaning mistake-proofing. The idea is to design systems so that errors are either impossible to make or immediately visible when they occur. Every component, every procedure, every protocol in the Shinkansen system is designed with poka-yoke in mind. How do we make it physically impossible for something to go wrong undetected? The tracks themselves are engineered to extraordinary tolerances. They are inspected nightly by automated vehicles called Dr. Yellow.
unmanned inspection trains that run at full speed along the Shinkansen lines, measuring track geometry, overhead wire condition, and rail wear with millimeter precision. When Dr. Yellow detects a deviation, even one that hasn't yet caused any problem, maintenance crews are dispatched before it becomes one. The trains themselves undergo maintenance cycles that would seem excessive anywhere else anymore. Every Shinkansen train is inspected after every single journey. Major overhauls happen on schedules measured in hours of operation, not years of use. Components are replaced before they wear out, not after they fail. The result is a system where mechanical failure, one of the most common causes of train delays in other countries, is vanishingly rare. When delays do happen in Japan, they are almost never caused by equipment breaking down. They are caused by things genuinely outside human control. Earthquakes, typhoons, someone on the tracks.
But engineering alone doesn't explain the punctuality, because the most precisely engineered machine in the world still depends on the people who run it. And in Japan, the people who run the trains are operating within a human culture as precisely engineered as the trains themselves. The foundational concept here is kaizen, a Japanese word meaning continuous improvement. Kaizen is not a corporate program or a management fad. It is a genuine cultural philosophy applied across Japanese industry for decades that says no process is ever finished. Every system can always be made slightly better. The goal is not perfection achieved. It is the permanent, ongoing pursuit of perfection. In the context of the railways, Kaizen means that every delay is analyzed, every near miss is documented, every inefficiency in boarding, signaling, scheduling, or maintenance is identified, studied, and incrementally improved. The people running the trains are not just executing a system, they are constantly refining it. This extends to the staff themselves. Train drivers in Japan undergo training that makes aviation pilot programs look casual. Mastering a single route, its braking points, its acceleration curves, its signals, its precise stopping positions takes months. Drivers practice with simulators before touching a real train. And once on the line, they are expected to stop within plus or minus 10 centimeters of the marked stopping point on the platform. Every time. Not occasional. Every single stop, every single day. That level of precision is not achievable through rules and supervision alone. It requires something internal, a personal standard, a professional pride, a sense that the schedule is not someone else's concern. It is yours. There's also a concept called shisakanko, pointing and calling. Every action a train operator takes is accompanied by a physical gesture and a spoken announcement. Before the train departs, the driver points at the signal and calls out its status. The conductor points at the platform edge and calls out that the doors are clear. Every critical check is verbalized and physicalized, turning an internal thought into an external, verifiable action. Studies have shown that pointing and calling reduces workplace errors by up to 85%. You'll see it not just on trains, but throughout Japanese industry, in factories, in aviation, in construction. It's a simple practice with a profound effect. It forces the human brain to be fully present for the actions that matter most. Even with perfect engineering and flawless staff performance, you still need a schedule that is actually achievable. And the schedules Japanese railways operate on are a masterpiece of logistical planning. Tokyo's rail network handles roughly 40 million passenger journeys per day. That's not a typo. 40 million every day on a web of over 40 different lines operated by multiple companies that all need to connect, transfer, and coordinate with each other. Building a timetable for this system is one of the most complex optimization problems in the world. Japanese rail planners use sophisticated computer modeling to calculate the precise timing of every train, every junction, every signal, accounting for the cascading effect that a single delay on one line can have on dozens of connecting services. Buffers are built into the schedule, but they are precise buffers, calculated to the second, not generous rounding that masks poor performance.
The idea is to build schedules that are genuinely achievable, then actually achieve them, rather than build in so much slack that the schedule itself becomes meaningless. When a disruption does occur, a door that takes 30 extra seconds to close, a passenger who needs assistance, a brief signal problem, dispatchers have real-time visibility across the entire network and can adjust downstream timings to absorb the delay before it compounds. This active management means that small problems are caught and corrected before they cascade into large ones. There's also a deeply practical element: passenger behavior. Japanese commuters board trains with a discipline that actively contributes to punctuality. People line up in marked positions on the platform, the exact spots where the train doors will open, before the train arrives. Boarding is orderly, efficient, and fast. Nobody pushes, nobody holds a door. The social contract between the railway and its passengers runs both ways. The train will be on time, and the passengers will make that possible.
No system, however well designed, is immune to disruption. And how a system handles failure is just as revealing as how it performs under normal conditions. Japan sits on one of the most seismically active regions on Earth. Earthquakes, typhoons, and extreme weather are not edge cases. They are regular features of Japanese life. The Shinkansen alone is halted by earthquake warnings multiple times per year. When this happens, the response is immediate and extraordinary. Japan's early warning system can detect a major earthquake and transmit a signal to halt all Shinkansen trains within seconds, before the shaking even reaches the tracks. The trains slow down and stop safely, passengers are informed, and the assessment process begins. After the 2011 Tohoku earthquake, one of the most powerful ever recorded, every Shinkansen on the network stopped automatically. The tracks were inspected over hundreds of kilometers. Minor damage was found in several places. Not a single train had derailed. Not a single passenger was injured. Trains were running again within days. When delays are unavoidable, weather, accidents, emergencies, Japanese railways communicate with a transparency and professionalism that is itself a form of punctuality. Passengers know exactly what is happening, why, and when service is expected to resume. The information is clear, accurate, and continuous. The uncertainty that makes delays in other countries feel so much worse is itself managed. And when a delay is caused by human error, an operational mistake, a miscommunication, the response is not to hide it or minimize it. It is documented, analyzed, and used as the basis for the next round of improvement. Because in a Kaizen culture, a mistake is not just a failure, it is data. So, why are Japanese trains never late? Because in Japan, never late isn't a marketing slogan. It's a standard. And the standard is maintained not by one thing, but by a complete system. Engineering, culture, training, scheduling, communication, and a philosophy of continuous improvement that treats every second of deviation as something worth understanding and fixing. It starts with trains so well built that they run for decades without mechanical failure. It continues with drivers who can stop 16 carriages within 10 centimeters of a mark, every single time. It is held together by schedulers who plan for 40 million journeys a day, and dispatchers who catch disruptions before they cascade. And it is reinforced by passengers who line up in the right spots and board in 30 seconds flat, because they understand they are part of the system too. The Shinkansen's 20-second early departure apology wasn't bureaucratic absurdity. It was a signal to every passenger, every employee, every competitor of exactly what kind of standard is being maintained here. Not approximately on time, not mostly on time, not on time within a reasonable margin. On time. Every time.